Hi everyone, and thank you for joining me to the Cloud Native Application Bundle session. In this session, I will be covering what is a Cloud Native Application Bundle, how it can be useful for your application, what are the different challenges Cloud Native Application Bundle solves, and I will be demonstrating some of the concepts, the tools, and so on. So before starting, let me introduce myself. My name is Idan Shahar, and I'm a Cloud Solutions Architect in Microsoft Middle East and Africa. I'm part of an organization that does partnership. This organization helps ISVs, partners, services partners, startups to be more successful using our technologies. I believe in my vision that technology can help us in our day-to-day life. And I want to give you some examples, and one example from my life. So my hobby is meat. I really like to cook meat in different methods. So smoker, barbecue, sous vide, and even oven. Now I want to talk with you about my smoker. I have a little smoker in my balcony, and that smoker is an IoT device. This smoker is connected to my Wi-Fi, so I can control it while I'm working for my home office. So I can prepare my dinner, I can control a different temperature, I can set threshold for the meat temperature, I can adjust the amount of the smoke in the smoker. So this is just one example of how technology can help us in our day-to-day life. So before starting, I want to let you know that I'm available for you in every single media. So you can reach out to me through email, Twitter, LinkedIn, and I don't know, maybe you'll find me somewhere in the cloud. So as you may know, Microsoft has changed. It's not the same company as it used to be a few years ago. Microsoft bought GitHub, and you have many things in Microsoft that contributing to the open source, creating new projects, contributing to existing projects. And today, we are here to talk about CNAB, the Cloud Native Application Bundle, an open source project that brought to you from Microsoft Azure, Docker, Bitnami, HashiCorp, and CodeFresh, and actually many other companies are also contributing to CNAB. It's also part of the CNCF organization. What are Cloud Native Application Bundles? CNABs, name it whatever you want, but this is a standard packaging format for distributed applications. So you can pack your application into one package all the way from the infrastructure side to the application side and everything that between both. No matter if there are configuration, bash scripts, and everything else, you can glue everything together into one package. It is cloud agnostic. You can compose the application package into every single cloud provider and even on premises. It helps you to deliver application across organizations, teams, marketplaces, and even offline. And it does it in a secured way. When you use CNAB, CNAB solves some challenges for you. And when I talk about these challenges, I like to separate them to three different standpoints: the developer standpoint, the DevOps standpoint, and everyone else's standpoint. So let's think about it. There are so many planes of controls, APIs, and tools you need to be aware of. And not just to be aware of, you need to know how to use them in order to install the application. So think about CNAB as an MSI installer for distributed applications. So from now on, when you use CNAB, you no longer need to go over endless readmes, copy-paste commands, and when you did one mistake, you need to destroy the whole environment and start all over again. So from the developer standpoint, it allows people to install your code easily. From the DevOps standpoint, it's an immutable entity for your distributed application. And from everyone else's standpoint, no longer readmes. Just use CNAB to install applications in one click. Great. So now when you understand what CNAB solves, we can start talk about what bundles are. So a bundle is a single file that contains the name of the bundle, the version of the bundle, some keywords and descriptions. It also has the invocation image. The invocation image is called the installer program. It has some parameters that you can override as a user because we want to make sure this package is parameterized so you can inject parameters all the way to your application. It also has the executable images and eventually environment variables and credential paths. So how do we use bundles? There are two tools we can use to use bundles. There's Duffel and Porter. So let's talk about Duffel. Duffel is a command line tool that interacts with cloud native application bundles. It allows you to package and unpackage distributed applications for deployments. It supports whatever cloud provider and services you want to use. When you use Duffel, you need to have a deep understanding of CNAB. Remember when I told you that there are two tools, Duffel and Porter? So why do we need Porter if we have Duffel? That's a good question. The answer for this question is simple. You can use both Porter or Duffel, but Porter is easier to use. You don't need to understand exactly how CNAB works. With Porter, you can take everything you need to deploy an application, from its application to the whole process, the command line tools, bash scripts, configuration, everything you need to deploy the application, and glue it together into one piece. Now, everyone can use your application, can deploy your application without understanding the whole deployment process, and they can just use it, or without following a step-by-step guideline. So why do we need Porter, and what is Porter? Porter is a command line tool. It securely handles secrets and credentials. It works with every single existing software, technology, tool you use to install your application today. So you can take advantage of everything you already done for your deployment, but then you can glue them together as one piece using Porter. So from now on, it's going to be a lot easier to install your application, to replicate it. And of course, it's reliable because everything there is consistent. The API versions, the tools, the CLI version, everything is dependable and consistent. So what are the different features Porter has? First of all, parameters. You can use parameters in your Porter YAML file, and these parameters can be pushed into your deployment, into your existing tools. So if you use Helm charts, you can make them parameterized through your Porter YAML file. It of course has credentials and secrets. And the most interesting thing about Porter is the output. Every single operation you do can have an output, and this can be a dependable output. It means that the next operation you're going to do can be dependent on the output that the previous operation did. This is an example for a Porter YAML file that installs WordPress on top of Azure Kubernetes Service. Now we will go over the different sections here and we will understand exactly what each of them does. Here we can see the name of the bundle, the package, the version, and the invocation image. Remember when we talked about invocation image that are part of the bundle file? So this is a reference for the CNAB bundles. We use mixings. Mixings are plugins that Porter use. This is our way to tell Porter what are the different tools we're going to use, the cloud provider. So in this case, I use Azure, I use the Azure API, and I use Helm to install my application on top of Kubernetes cluster. Then I have credentials. I want to make sure my deployment will be secured. So I use credentials that are stored in my laptop. I also have parameters. I can define parameters that will be passed into my deployment, into my application, into my configuration. So in this case, I have the MySQL user. Now, when I will be installing the MySQL machine on top of Azure, I will be able to use this parameter as MySQL user into my database. So I define my username and the password and the server name and the database name from parameters. Remember when I talked with you about outputs? So this is really important. In this case, when the database is ready, we will be getting an output from the deployment. This output will be used later on when we want to deploy our application. So this section won't start until this output will be ready. Now, once we have the output from MySQL host machine, I can go over to install the Helm chart. So I have my Helm chart, and I'm passing parameters into my Helm chart. So I'm passing the MySQL host, so my application will be able to communicate with the database. I'm also passing the MySQL username, the password, and the database name. As you can see, there are a little bit differences between the MySQL host than the MySQL user. Both are parameters, but this parameter has made by the output from the previous deployment, from the provisioning of the MySQL machine. Now remember, this one assuming we have already an existing AKS service. But if you want, you can also create the infrastructure, so you can create your own Kubernetes service as part of your deployment in Porter. Remember that I told you that Porter is pretty easy to use and pretty easy to install? So now let's see how easy it is to install Porter. If you are curious about how to get started with Porter, you should start with browsing porter.sh. This will bring you to the Porter website, where you can find all of the docs and the installation instructions, quick start demos, the blog, the link for GitHub, and everything. So let's start with installing Porter. So I'm using Mac OS. So in this case, I'll be copying the first command. Now I'll use my terminal to install Porter. Now it's downloading Porter, and I will be able to use Porter in a moment. As you can see, it's also installing some mixings: Kubernetes mixing, Helm mixing, ARM mixing, Terraform mixing, and so on. Great. So now I have Porter installed in my machine. Now let's see what can I do with Porter. Now, we have a lot of commands we can use with Porter. We can archive a bundle from a tag, we can build bundles, we can create bundles, we can copy bundles, we can explain bundles, we can inspect bundles, install them, invoke them, link them, list the installed bundles I have, publish a bundle, show an installation of bundle, uninstall and upgrade a bundle. So this is how I installed Porter in my machine. Okay, so we've got Porter installed, and we can start to use Porter. So before moving to the next demo, I want to spend a few more moments to discuss about why Porter is so useful for us. Let's talk about infrastructure as code. Infrastructure as code is a concept that lets us codify everything we do in our infrastructure. So from now on, we can look on our infrastructure as the same way we used to look on our code. So we can use source control for our infrastructure. Now this motion we're familiar with it. With Porter, we apply this motion into our infrastructure and into our application together. So think about it. Today, If you used to start working on your infrastructure, you mostly do a lot of manual stuff. Now, when you wanted to upgrade your environment, it become a little bit complicated because then you had to do another manual stuff, and if you need to replicate it between different environments, it's even become harder. When you apply infrastructure as code tools, it lets you automate everything. So you can create the service, the infrastructure with an automation, and then you can replicate the upgrade with another automation, and then you can replicate it between different environments. Now, it becomes harder when you want to wire it up together with the application itself. So you already installed your infrastructure, and now you need to upgrade the application. So it's another step that you're gonna do, maybe with your CI/CD, maybe manually, but no one before helped you to wrap it up together with the infrastructure. So no one before gave you the option to connect it to the infrastructure installation together. If you want to see some examples, go ahead and scan the QR code. And I think that is a good time to start the demo. So I want to start with creating a service principal in Azure. So my porter will be able to communicate with my Azure portal, with my Azure account, and we will be able to create new resources in my portal. In this case, I already created one, so I just wanted you to see the command that I used to create my service principal. Once I created the service principal, I will have an output of the client ID, the client secret, and the tenant ID. Now I'm gonna generate the credentials, and I'm gonna pass them as environment variable into Porter. Porter will use these environment variables and will create credentials out of it. So it will be able to communicate with my portal and with other services I'm gonna use in a secured way. So now you can see I'm typing the environment variables that I defined in my machine. Now let's have a look on the existing credentials I have and the new one that I just added. As you can see, I just added a new credential that's named Azure. It added 5 seconds ago. Using Porter build, we generate the bundle. As you can see, creating a Dockerfile, building a Dockerfile, copy every single mixin needed in my Porter, and starting the invocation image build. So it's building the image with everything required in order to run this image and actually create the deployment. Now let's see what's happened. So I can see that I have a new Docker file, and as well as I have a new folder, the .cnab. In this folder, we have everything we need for our bundle. Now I want to start the deployment. So I will export a new environment variable. I'll call it install ID. And I'm going to use it as a unique ID for my deployment. Now let's move forward and start the deployment. So I'm using the Porter install command. I'm passing the credentials I created. And I'll also defining the resource group for my cluster, for my installation, for my Cosmos DB, for my Kubernetes cluster, I'm telling Porter which region I'm gonna use, and basically that's it. Now the deployment has started, and we will be able to see in a few moments the deployment is ready in my portal, and as well as we will be able to see a new deployment in my Kubernetes cluster. While it's being created, I think it's a good timing to look on the Bundlejson file. If you remember, we spoke about it in the beginning of the presentation. So as we can see, there are the credentials in the Bundlejson file. There are some keywords. Here is an example for the mixings we use in Porter. As well as there are some definitions and of course parameters and invocation image. The invocation image is made by Porter in this case, and it's a Docker image. Also, there are parameters that we use in our Porter. For example, we have the resource group and the name for the cluster and so on. And eventually we have the version for the bundle itself. By now, our deployment is almost ready. We can see that our cluster is up and running. Helm has initiated on the cluster. We configured the RBAC roles for the Helm tiller, and now Cosmos DB is being created. While the Cosmos DB deployment is in progress, let's have a look on the Porter YAML file. As you remember, we spoke about bundles. Now let's see what are the different specifications we have in our Porter YAML file. So we have the name of the bundle, the version of the bundle, description, the Dockerfile. Let's have a look on the Dockerfile in a moment. In the Dockerfile, we can see that we install everything is needed in order to be able to interact with Azure in this case. So this is the invocable image. Great. Back to the Porter YAML file. As you can see, there are mixins we are using, the plugins that tells our Porter what are the cloud providers we are going to use, what are the different tools we're going to use. Then we want to install AKS, Azure Kubernetes Service. So we need to specify the different parameters we have for our AKS cluster. And as well as we will have the deployment file for the specific AKS in our ARM template. So we define the name of the cluster, some resource groups, the client ID and the secret for the cluster, so the cluster would be able to communicate with our cloud provider with Azure. Then we want to log into Azure, so we use the Azure CLI command in order to log into our portal, or in this case to our CLI. So we will be able to deploy the deployment into Azure. So this is how we do the set subscription command, because I have different subscriptions, so I wanted to make sure I'm deploying the resources into the right subscription. Then I want to fetch the credentials for my cluster after creating the cluster. So this cluster, I will be using it in order to deploy the application into it with using Helm. Once I created the cluster, I want to add RBAC roles for the tiller, so the tiller will be able to have permissions in the cluster. Then I initiated Helm in the cluster, and now I'm moving to install Cosmos DB on Azure. As you can see, I also specified the resource group for the Cosmos DB. As you can see, in this case, I also use ARM template to install Cosmos DB. I need to define the resource group for my cluster, the service name, the location in Azure, the region that I'm going to use. Then, of course, we're going to use output because we want to make sure our application, our Helm chart, is connected to the database. So we're going to inject the output from the Cosmos DB into my Helm chart. As you can see, this is my Helm chart. It also exists in the directory here. This is how I integrated my Helm chart with my Cosmos DB. In the last part, is the uninstall. We want people to be able to uninstall our application. As you remember, we use credentials and we use parameters. So both are here downstairs. I also define default values so the user can override them in case it's needed. We can see that the Cosmos DB deployment is still in progress. So let's have a look on the ARM template we created for the AKS cluster and as well as for the Cosmos DB. Let's have a look on my Azure Kubernetes Service template, which is an ARM template. ARM is the official infrastructure as code template for Azure services. You can create everything you do in ARM template. Actually, every single resource in Azure is represented by ARM template. So you can define everything here, from the virtual networks for the DNS services, the disk size, the size of the cluster, how many nodes we're going to have in the cluster, the version of the cluster. So in this case, we specified this specific version. Sorry. Okay, good. Now let's have a look on the Cosmos DB template. It is the same concept, but for our Cosmos DB resource. So we specify the resource group as well. This is a parameter. So we can pass the resource group from our parameter files. In this case, we're passing the resource group from our Porter template, from our Porter JSON file, which is also represented by parameters that we passed into our Porter JSON file when we just installed the Porter file. We decided to use a MongoDB type for our Cosmos DB service. And this is it. Now let's see if our deployment has finished. I'm sure it's going to be there in a moment. It is almost ready. Helm just finished installing Spring Music demo application on top of our cluster. Now let's understand what's going on here. As you can see, the external IP is still pending. It means a new IP is being provisioned into the load balancer. We can see that the pod is running and the service is still pending. In a few moments, it will be ready and we will be able to browse into our application. I'm using the watch command so I can see the progress of the resources creation, in this case, a service creation. This is it. Our application is ready. We have a public IP, so let's browse into our application and see what's going on there. Okay, so I'll open the website. Just move it here into the main screen. So this is our application. We have the albums. This is the Spring Music application. Now let's move to the Azure portal and we'll see what are the resources Porter created for us. So we can see this is the resource group we created with Porter. We have an Azure Kubernetes service there and as well as Cosmos DB. This is my Cosmos DB. If you are interested in how to learn Cosmos DB, you can hit the quick start. Now let's move back to the resource group and we'll see our Kubernetes cluster. So this is AKS. This is a managed Kubernetes cluster. We can see that it's in the right version. This is an East US region. We have 3 nodes in the cluster and we use kubectl. Great. I hope you enjoyed the demo. Now let's have a short recap of what we had today. So we spoke about Cloud Native Application Bundles. What is the Cloud Native Application Bundle? What challenges CNAB solves for us? Then we moved to discuss about bundles. What is a bundle and how does a bundle file look like? Then I explained that there are two different tools we can use to interact with Cloud Native Application bundles. We have Dockerfile, that is a little bit more complicated. It's a command line tool and it requires a deep understanding of CNAB. Then we have Porter. We discussed about Porter and we even showed some demos about Porter. Porter is a command line tool. Everything there is YAMLized, so you don't need to write bash scripts, Dockerfile, command lines and everything. It's just a simple tool that lets you to take advantage of your existing tools that you already used for your deployment and build CNAB packages out of your deployment. So it's going to be a lot easier to use them next time. Great. So I think we covered a lot today. If you have any questions, you can feel free to reach out to me directly. I'm available for you. You can send me an email, you can reach out to me in LinkedIn or via Twitter. So thank you very much for joining the session today, and I hope you enjoyed and I hope to see you next time. Bye bye.